Welcome to our presentation. Today we are going to talk about transducers which have become an integral part of our daily lives. The aim of this presentation is to describe the transducers that we encounter in many fields, especially in the fields of engineering, to talk about the technical features of the transducers, to explain the usage areas of transducers, and to classify the transducers. Um, First of all, I want to talk about what a transducer is and what it is used for. Is it now that the foundation of transducers, which we encounter in many fields, were laid out in the 1800s with various experiments? Transducers are electronic devices that perform the transduction process. Transduction is the process of converting one of form of energy into another one. Thanks to the transduction process, transducers can convert many energies such as mechanical, electrical, optical, magnetic, and thermal. Now, also will explain the technical features, working principles, and usage areas of the transducers.
First of all, I want to talk about technical characteristics of transducer. Transducers mostly consist of two main parts, a sensor and signal conditioning unit. Transducers also have other important parts such as signal processing equipment, amplifier, and power supplies. Sensors are one of the main parts of transducers. Sensors, temperature, velocity, flow, level, pressure, etc. detects the change in any physical quantity form into input part and reflects them as change in output quantity. Both the input and output quantities of the sensor are physical. Another main part of the transducers is the signal conditioning unit. The signal conditioning unit converts the physical output of the sensor into a proportional electrical signal. Now I will talk about the working principle of the transducers. Transducers transmit the physical quantity they detect with their sensors in response to signal conditioning unit with the input rate. The signal conditioning unit converts the physical response from the sensor into proportional electrical signal. In short, transducers provide the conversion from physical reaction to the electric response. Finally, I will talk about the usage fields of transducers. Transducers, which we encounter in many fields such as health, transportation, communication, and defense industry today, enable physical stimuli to convert into electrical signals, and values can be easily determined using gauger. Since it's difficult to determine the exact magnitude of physical force. Converting a physical quantity into electrical signal, which is primary function of transducers, is used in almost every field. For example, in thermal cameras used in security fields, we see that physical energy such as heat is transformed into image form thanks to transducers. Another area where transducers are commonly encountered is biomedical instrumentation such as ultrasound machine, EKG, and MRI. Various transducers are also used areas in such as defense industry, robotics, and civil construction. To summarize, we use more than one transducer in our daily life. Most electrical applications or tools contain a transducer.
Thanks to also for information. And as also said, there are many types of transducers since most electrical devices or tools contain a transducer. Type of transducers, it can be classified under six main headings. Types of transducers by power source, output conversion-based transducers, analog and digital transducers, inverse transducers, transducers by working principle, transducers that measure physical quantities by quantity. Now, IBK and Bora will classify transducers types.
By classifying the transducers, I will first talk about the types of transducers according to the power source. According to the power source, the transducers are divided into two as active and passive. According to the external power they use, the active transducer transduces various physical stimuli into electrical signals using the energy from it without the need for an external power source. Photoelectric, piezoelectric, magnetostrictive, electromechanical, ionization, electrochemical, Hall effects, thermoelectric are examples of active transducers. The passive transducer transduces various physical stimuli into electrical signals using the energy it receives from outside, which needs an external power source. Resistive, capacitive, inductive transducers are examples of passive transducers. Transducers types can be classified as output, conversion-based transducers. Transducers are classified as primary and secondary based on their outputs. Primary transducers transduce the physical stimulus into a mechanical signal. Since the primary goal of the transducers is to transduce the physical stimulus into an electrical signal, the mechanical output from the primary transducer is reprocessed in the secondary transducer. Secondary transducers obtain electrical signals by transducing the mechanical response of the primary transducer from the physical signal. The electrical signals obtained in the output signals are directly proportional to the mechanical signals transferred from the primary transducer. Analog and digital transducers are another type of transducer. Analog transducers transduce physical quantity into analog electrical signals. The output from an analog transducer is continuous in magnitude and time. Examples of thermistor, thermocouple, and piezoelectric analog transducers can be given. A digital transducer transduces a physical quantity into a digital electrical signal. The output from a digital transducer is discrete and not continuous in magnitude and time. Another type of transducer is invert transducers. Inverting transducers technically do the exact opposite of transducing physical quantity to an electrical signal that transducers do. That is, inverse transducers transduce electrical energy into any other form of energy. Speaker, display, servo motor can be given as example of inverse transducers. Now Bora will continue with the rest of the topic.
When classifying transducers, we can divide them into various types according to their working principles. These are photovoltaic, photoconductor, piezoelectric, inductive, Hall effect, thermoelectric, electrostatic, and electromechanical transducer. Photovoltaic transducers convert light energy into electrical energy. In addition, photovoltaic transducers are active transducers. That is, they produce their own energy. Solar cells are examples of photovoltaic transducers. Photoconductors, the conductivity of transducers depends on the light intensity. It has been observed that the conductivity of photoconductor transducers increases as the intensity of light increases. They transduce the light intensity into an electrical signal. Piezoelectric transducers convert physical force, such as pressure, into electrical energy. Piezoelectric transducers are used to measure the change in pressure, acceleration, force. Microphones that detect the pressure exerted by sound energy and transduce this physical force into an electrical signal are examples of piezoelectric transducers. An inductive transducer working on the principle of electromagnetic induction measures the change in inductance between two coils. Physical quantities such as displacement, force, torque, acceleration can be measured by changing the inductance thanks to the moving core between the coils of the inductive transducer. The Hall effect transducer detects the magnetic field and converts it into an electrical signal proportional to its size. Proximity and position detection, speed detection in tachometer are the usage areas of Hall effect transducer. Thermoelectric transducers convert thermal energy into electrical energy. Thermoelectric transducers have one thermocouple, two terminals. They convert thermal energy into electrical signals according to the temperature difference between their terminals. Electrostatic transducers have two electrodes. One of the electrodes with opposite poles is movable and the other is fixed. When the moving electrode moves, it causes a voltage change. Electromechanical transducers convert mechanical energy into electrical signals. Mechanical displacement and positioning are the usage areas of electromechanical transducers. We can categorize transducers by physical quantity by quantity. These are pressure, temperature, ultrasonic, displacement flow, inductive, strain gauge, acceleration transducers. Pressure transducers detect the applied pressure with the elastic material it has and convert it into an electrical signal. Pressure transducers are used to monitor the flow of substances and measure pressure. Temperature transducers sense temperature and convert it into an electrical signal. Thermocouples and thermistors can be given as example of the temperature transducers. Temperature transducers are used to control and maintain temperature. Ultrasonic transducers convert ultrasonic waves into electrical signals. Ultrasonic transducers are used to detect objects, measure the distance between the object and the transducer. Displacement transducers convert linear motion or vibration into an electrical signal. They are used to detect the position of an object or its change in displacement. Linear variable differential transformer and potentiometer displacement transducers can be given as examples. Flow transducers convert the physical quantity sensed by the flow of gases or liquids into electrical signals. Flow transducers are used to measure the flow rate of gases and liquids. Inductive transducers work on the principle of electromagnetic induction thanks to the coil that creates a magnetic field by itself. When a conductive object, such as metal, enters this magnetic field, the inductance changes. It is possible to encounter inductive transducers in proximity sensors, metal detectors, object counters. Strain gauge transducers convert physical quantities such as mechanical stress into an electrical signal. It has a flexible and conductive material that doesn't break when force is applied to it. Strain gauge transducers are often used in civil engineering. Finally, acceleration transducers detect the acceleration of any object and convert it into an electrical signal. Acceleration transducers can also be accelerometers. It is also used to measure the electric acceleration caused by the force applied to object.
Thanks to Aybüke and Bora for their information. We came to the end of our presentation. Thanks for watching.